Subscribe to the channel so you don't miss out on any of these videos. Imagine this: you're floating in space, far beyond any star, planet, or galaxy you've ever seen. All around you is a vast, silent darkness, so complete it's like you've stepped out of reality itself. You keep going, drifting deeper into the unknown, and you start to wonder, is there an edge to this endless void? Is there a point where it all just stops? Or does space go on forever, in every direction, like some cosmic loop we're too small to understand? Right now, you're standing on the brink of one of the biggest mysteries in science and the biggest questions in human imagination. What lies beyond the universe? Now, here's where things get even stranger. Everything we can see, all the stars, planets, galaxies, and cosmic dust, only makes up a fraction of what's out there. The farthest points of light we can detect mark what scientists call the observable universe. That's the limit of how far we can see, but it's definitely not the limit of the universe itself. In fact, there might be so much more beyond that horizon that we can't even begin to imagine. Some believe there's another whole universe out there, beyond the one we know. Others think space itself could fold back around, like we're all living on the surface of a four-dimensional sphere. So, let's dig in and get a little mind-bent, because exploring this question means diving deep into some of the most mind-bending ideas in science: multiverse theories, cosmic boundaries, and the very fabric of space-time. Stick with me, because the edge of the universe might be way stranger, and way closer, than anyone ever expected. The universe, as we know it, is made up of countless galaxies, stars, and other cosmic wonders spread across what we measure as billions of light years. When we look out into space, we're looking back in time. The light from distant stars and galaxies takes millions, even billions of years to reach us. So, the farther we look, the older the light we're seeing. It's like looking at an ancient photo album of the cosmos. But eventually, we hit a point where the light is so old it's from the beginning of time itself, the Big Bang, around 13.8 billion years ago. This edge of the observable universe is not a wall or a barrier we could reach or touch. It's a limit defined by the distance light has had time to travel since the beginning of the universe. Beyond that, we're in the dark, literally. And scientists are left wondering if we're looking out at an edge, or just our limit of perception. It's like being stuck inside a room with no windows and no doors. You know there's something outside, but no way to see or measure it. All we can see is a bubble, around us, about 93 billion light-years across. Let's go deeper. When we talk about edges in space, we're often picturing something like the edge of a table. But space doesn't really work that way. Imagine if you were an ant crawling around on a balloon. As you move, it seems like you could go on forever. But if you traveled long enough, you'd end up right back where you started. Some scientists think the universe might be like that. Instead of having an edge, it could be curved back on itself in higher dimensions. That means if you traveled in a straight line for long enough, you'd eventually end up back where you started, like you were going around the surface of an invisible four-dimensional shape. The idea that space could wrap back on itself is hard to picture, but it would mean that the universe has no edges, just an endless loop. Then there's the possibility of other universes. The idea of a multiverse suggests that our universe might be one of an infinite number of universes, each with its own rules, dimensions, and maybe even different forms of life or matter. Some theories say these universes could be stacked next to each other, like pages in a book, or they could be infinitely far apart. Some might be exact copies of ours, while others could be completely alien, with laws of physics we can't imagine. This multiverse theory is partly inspired by quantum mechanics, the science of the tiniest particles in the universe, where the idea of multiple possibilities happening all at once seems to be baked into reality itself. Imagine that each time you make a decision, a new universe splits off where a different choice was made. This concept is called the many worlds interpretation, and it suggests that there could be countless versions of you out there, living different lives in different universes. But these other universes wouldn't just be copies of ours, they could be vastly different. Some might be made of dark matter, with no light at all. Others might have entirely different physical constants, where stars don't form, or life is completely impossible. So if these other universes exist, where are they? Well, that's part of the mystery. Some scientists think these universes could be in separate dimensions, places we can never physically reach or even see. Others think they might be closer than we think, separated by only tiny distances, but on a level we can't interact with. Imagine 2 pages in a book, so close they're almost touching, but they're completely separate worlds. And here's where it gets even wilder. Some scientists think there could be a kind of cosmic landscape of universes, where different parts of the multiverse have different laws of physics. It's like an infinite field of possibilities, with each universe being a little bubble, floating around in this cosmic sea. Some bubbles might pop, or merge with others, creating entirely new universes with strange new rules. Others might collapse in on themselves, disappearing forever. This idea comes from something called string theory, which is a field of physics that tries to explain the basic building blocks of reality. According to some versions of string theory, our universe might be just one tiny bubble in a much bigger, multidimensional space filled with countless other bubbles, each representing a different universe. But wait, what does dimension even mean here? Most of us are familiar with the 3 spatial dimensions: length, width, and height, and the 4th dimension, which is time. But string theory proposes that there could be more dimensions out there, ones that we can't perceive but still affect the way the universe works. Think of it like living on a piece of paper. If you were a 2-dimensional creature, you'd only know the world of that flat sheet. You wouldn't be able to comprehend up or down, but those directions would still exist. In the same way, we might be living in a 3-dimensional bubble, but higher dimensions could be all around us, shaping reality in ways we can't see. Then there's another question. If there are edges or boundaries, can we cross them? What happens if you go too far? One theory says that at the edge of our universe, the laws of physics might start to break down. It would be like driving off a map. Everything we understand about reality might start to change. Light might bend in impossible ways, or time might run backward. This idea, though, is mostly speculative, because we have no way to test what might happen at the outer reaches of the universe. But it opens up all kinds of wild possibilities, like the idea that the universe could be torn open, revealing another universe on the other side. Some theories even suggest that black holes could be gateways to other universes. Black holes are strange enough on their own, with gravity so intense that nothing, not even light, can escape. But some scientists think that if you were to somehow survive falling into a black hole, you might come out in an entirely different universe. It's all speculation, of course, but it raises the idea that black holes could act as cosmic doorways, connecting different universes like tunnels in space-time. Imagine what could be on the other side of one of these doors: entire galaxies, strange new forms of matter, or even intelligent life that evolved under totally different physical laws. And what about time itself? If the universe has an edge, does time stop there? Does reality just end? It's a question physicists have wrestled with for a long time. Some theories suggest that time might be tied to the expansion of the universe, meaning that if you reached an edge, time itself could cease to exist. You'd be stepping into a place where cause and effect, past and future, don't have any meaning. So, imagine standing on the edge of the universe, where time itself seems to fall apart. What would that even feel like? We're used to time flowing in one direction, always moving forward, but at the edge of the universe, it's possible that time behaves in ways we can't even comprehend. This idea comes up in theories related to space-time, where time is treated as a dimension that's woven together with the fabric of space. So, in the same way that we move through space, we're also constantly moving through time. But if you get to a place where space itself starts to bend or loop, time might follow suit. You could experience time slowing down, speeding up, or even looping back on itself in a kind of infinite cycle. And then there's the wild idea of timeless regions. Some scientists speculate that, beyond the observable universe, there could be places where time doesn't exist at all. In those regions, reality wouldn't be like anything we know. It would be a kind of frozen state, where events don't happen, change doesn't occur, and nothing evolves or ages. It's as if reality itself would be paused, like a video put on hold. Imagine if you were somehow able to step into one of these timeless regions. You might find yourself trapped in a moment that never ends, a place where there's no future, no past, just an endless now. The edge of the universe, if there even is one, could also be a point where the known laws of physics break down completely. Right now, the rules of physics as we understand them apply everywhere we can see. Gravity works the same way in distant galaxies as it does here on Earth. But if you were to move beyond the observable universe, you might find yourself in a place where those rules no longer hold. For example, imagine a place where gravity is suddenly reversed, where particles behave in completely unpredictable ways, or where the speed of light isn't the cosmic limit anymore. We simply don't know what could happen if you cross this boundary into the truly unknown. But maybe the universe isn't infinite at all. Some theories propose that the universe has a finite size but no edges. This would mean that, just like the ant on the balloon we talked about earlier, you could keep traveling in any direction and eventually find yourself back where you started, without ever encountering a boundary. This idea of a closed universe is incredibly hard to wrap our heads around, because it doesn't line up with how we're used to thinking about space. If the universe is closed, then it could be like a three-dimensional version of the balloon, constantly expanding, but with no beginning, end, or edge. Another fascinating concept is the idea of a cosmic horizon. This horizon is like a wall in the sky where everything beyond it becomes invisible to us. The reason we can't see beyond this horizon has to do with the speed of light. Since light takes time to travel, there are parts of the universe so far away that their light hasn't had time to reach us yet. So, in a way, this cosmic horizon marks the limit of our cosmic knowledge. Anything beyond it is invisible, hidden from us not because it doesn't exist, but because its light hasn't gotten here yet. It's a bit like standing on the shore of an ocean. You can see the water stretching out to the horizon, but you know there's more out there, beyond what you can see. And here's a mind-bending twist. As the universe keeps expanding, some galaxies and stars are actually moving away from us faster than the speed of light. This might sound impossible, but it's due to the expansion of space itself. As space stretches, it carries galaxies along with it, making them recede from us at incredible speeds. For these objects, no matter how long we wait, their light will never reach us. They're beyond our cosmic horizon, locked away forever in the unreachable parts of the universe. Now, let's dive into the idea of an expanding universe. It's mind-boggling to think that space itself is getting bigger every second. Scientists discovered this by observing that galaxies appear to be moving away from us, with more distant galaxies receding faster than those closer to us. This discovery led to the idea that the universe began with a massive explosion, the Big Bang, and has been expanding ever since. But what's causing this expansion? Well, here's where things get strange. Scientists believe that a mysterious force called dark energy is driving this expansion, pushing galaxies apart and accelerating the rate at which they're moving away from each other. But what exactly is dark energy? The truth is, we don't really know. Dark energy makes up about 68% of the universe, but it's invisible and undetectable except through its effects on cosmic expansion. It's like an invisible hand that's pushing the universe outward, but we can't see it or measure it directly. And here's the kicker. If dark energy keeps driving the universe's expansion, then it's possible that everything we see, the stars, galaxies, and even atoms themselves, could eventually be stretched so far apart that they become isolated in a vast, dark void. This hypothetical end of the universe is sometimes called the Big Freeze, or heat death, a state where all matter and energy are spread out so thinly that nothing can happen. In this scenario, the universe becomes a cold, empty place, with no stars, no light, and no way for life to exist. Then again, there's another, wilder possibility. Instead of spreading out forever, the universe could eventually stop expanding and start collapsing back in on itself. This is called the Big Crunch theory. If dark energy weakens over time, the force of gravity could eventually overcome the expansion, pulling galaxies back together until everything converges in a massive, fiery collapse. In a Big Crunch scenario, the universe would end as it began, in a hot, dense state, possibly setting the stage for another Big Bang to occur and a new universe to be born. It's a cosmic cycle, like a phoenix rising from the ashes, but on an unimaginably vast scale. And let's not forget the possibility of a Big Rip. This theory suggests that if dark energy's effect continues to increase, it could eventually tear apart galaxies, stars, planets, and even atoms themselves. In a Big Rip, space itself would be pulled apart faster and faster until every structure in the universe is torn to shreds. Imagine planets dissolving, stars exploding, and eventually even atoms splitting apart in a final, catastrophic unraveling. It's a terrifying thought, and it would mean the end of reality, as we know it. All of these theories, whether the universe ends in a big freeze, big crunch, or big rip, are part of our attempts to understand the ultimate fate of everything. But what if our universe isn't the only one? What if the cosmos is just one small part of an even larger reality? This is where multiverse theories come into play. One idea called eternal inflation suggests that our universe is just one bubble in an endless sea of universes. According to this theory, during the Big Bang, some regions of space continued to expand, creating new bubbles, or universes, all the time. Each bubble could have its own Big Bang, with its own physical laws, dimensions, and even types of matter. Eternal inflation is just one multiverse theory, though. Another idea comes from quantum mechanics, which says that particles exist in a state of probability, with every possible outcome happening simultaneously. When you measure a particle, it collapses into a single outcome, but some scientists believe that the other possibilities don't just disappear, they create parallel universes. This many worlds interpretation suggests that every possible outcome of every event creates a new universe. So, every time you make a choice, a new universe is born where you made a different decision. If this is true, there could be an infinite number of you out there, living different lives in different worlds. And then there's the concept of brain theory, which comes from string theory. String theory proposes that all particles and forces in the universe are made up of tiny vibrating strings, and that there are additional hidden dimensions beyond the familiar three of space and one of time. In brain theory, our universe might be a three-dimensional brain, floating in a higher dimensional space, like a sheet of paper floating in a larger room. Other brains, representing other universes, could be floating right next to ours, separated by tiny distances in higher dimensions that we can't perceive. According to brain theory, these other universes could sometimes bump into ours, causing events we experience as Big Bangs. This means our universe might be part of a much larger multiverse, where collisions between brains create new universes, each with its own set of physical laws. Imagine two parallel sheets of paper floating close together. They might touch briefly and then move apart, creating a burst of energy in the process. That's one way scientists think our universe could have been born. And if that's not enough to blow your mind, consider the holographic principle. This theory suggests that our entire universe might be a hologram, a three-dimensional projection of information stored on a two-dimensional surface. In this view, the edge of the universe could actually be a boundary where all the information about our universe is encoded. Everything we experience in 3 dimensions could be a projection from this two-dimensional boundary. It's a bit like the way a hologram on a credit card creates the illusion of depth and has height, width, and depth, even though it's actually flat. If our universe is a hologram, then what we perceive as reality, space, time, stars, galaxies, could all be a kind of grand illusion, encoded on a distant boundary we can't see or touch. This would mean that everything we know exists not as solid, physical matter, but as layers of information that give rise to our perception of reality. Imagine the implications of this holographic universe. It would mean that every atom, every particle, every moment of your life is somehow encoded on the edge of the universe. And if this boundary holds all the information, it might also hold the past, present, and future in a kind of cosmic record that's always there. This brings us back to a question that humanity has pondered for ages. If there is an edge to the universe or a boundary where everything is stored, what lies beyond it? Well, here's where things get deeply speculative and mysterious. Some physicists suggest that beyond the boundaries of our observable universe, there could be an infinite expanse of other universes, each with its own unique properties, dimensions, and forms of matter. This is the multiverse idea taken to the extreme, an endless sea of universes beyond our cosmic horizon. If this were true, then our universe might be just one drop in an endless ocean, with universes beyond us that follow laws of physics we can't even begin to understand. What's beyond the multiverse, though? This question might be unanswerable, but some theorists speculate that all the universes could be part of a single, higher-dimensional structure, a kind of meta-universe that contains everything. In this grand framework, all universes, including ours, would be like cells in an organism, each contributing to a larger whole. This could mean that the multiverse itself is just one layer in an even more complex, infinite reality. But if that's the case, it's likely that we'll never be able to directly observe this meta-universe, as it might exist in dimensions beyond anything we can perceive. To add even more mystery, some scientists propose that the multiverse could interact with our universe in subtle ways. For instance, tiny fluctuations in the cosmic microwave background, the faint glow left over from the Big Bang, might be hints of interactions with other universes. Imagine if the energy from another universe occasionally leaks into ours, creating ripples or anomalies that we could potentially detect. These cosmic bruises would be faint, but they could give us a tantalizing hint that we're not alone in the larger multiverse. And then, of course, there's the ultimate question of why? Why is there anything at all? Why do we have a universe, or multiverse, instead of nothing? This is perhaps the biggest mystery of all, one that science may never fully answer. Some scientists propose that our universe exists because of something called the anthropic principle. This principle suggests that the universe has the conditions necessary for life simply because if it didn't, we wouldn't be here to observe it. In other words, the reason we see a universe with stars, planets, and complex structures is because those are the conditions that allow observers like us to exist. Could it be that the universe, or even the multiverse, is part of a larger conscious entity? This idea sounds far-fetched to many scientists, but it does raise interesting questions about the nature of consciousness and reality. After all, we still don't fully understand consciousness, how subjective experiences arise from physical processes in the brain. If consciousness is somehow woven into the fabric of reality, it might mean that the universe is more than just matter and energy. It could have an underlying awareness that we're all connected to. All of these ideas, the multiverse, cosmic horizons, timeless regions, and the possibility of a holographic universe, are part of our attempt to understand the mystery of existence. At the end of the day, we're still just scratching the surface, and every answer seems to bring up even more questions. The deeper we go, the more we realize how vast, strange, and beautiful the cosmos is. And maybe that's the real magic of exploring space. It reminds us that we're part of something much larger, a universe filled with mysteries that challenge us to keep asking questions and seeking answers. As we look out into the night sky, wondering what lies beyond, perhaps the most awe-inspiring thought of all is that we're still here, capable of wondering. Our journey to the edge of the universe and beyond isn't just a scientific quest, it's a testament to our unending curiosity, our desire to understand, and our search for meaning in a cosmos that may be far stranger than anything we can imagine. And so, we find ourselves in this endless cosmic dance, always pushing the boundaries of what we know and forever trying to peek beyond the veil of the universe. There's something deeply humbling in realizing that as much as we've discovered, there's a vastness still beyond our reach. We're aware of this universe that started with a Big Bang, a singularity exploding into the vast cosmos we see today, but we still wonder if that's the full story. What if our universe didn't emerge alone? Could there be other beginnings, other Big Bangs, lighting up realms beyond ours? One particularly fascinating concept that scientists propose is the idea of eternal inflation. It suggests that the Big Bang that created our universe may be one of countless others happening continuously, leading to an infinite number of universes, each with its own laws of physics, matter, and energy. Imagine our universe as just one bubble in a vast cosmic foam, where each bubble is a universe of its own. If eternal inflation is real, then the universe is far from unique. Our existence might be just one of many different bubbles, forming, evolving, and perhaps even colliding in this cosmic sea. The theory of eternal inflation opens up countless possibilities about what exists beyond our observable universe. For instance, in some of these other bubbles, the fundamental constants, like gravity, electromagnetism, or the speed of light, might be different. Imagine a universe where gravity is so weak that galaxies never form, or one where stars burn so quickly that life could never take hold. The existence of multiple universes with different conditions might mean that we're in a sort of Goldilocks universe, one where conditions are just right for stars, planets, and life as we know it. Now, here's where things get even more mind-bending. Some researchers suggest that these parallel universes might not just exist as faraway realms, but that they could interact with ours in subtle ways. We may never see these other universes directly, but they might influence ours, leaving faint imprints in the cosmic microwave background or influencing the way certain particles behave. The implications are staggering. What if some of the strange phenomena we see in our universe are actually caused by the gravity, or pull, of other universes just beyond our cosmic horizon? In some theoretical frameworks, these interactions could be the explanation for certain anomalies we can't otherwise explain. For example, there are strange regions in the universe where galaxies seem to be moving in the same direction, as if being pulled by some invisible force. This dark flow is still largely a mystery, but one possibility is that it's the gravitational influence of a massive object outside our observable universe. Could it be that we're feeling the effects of something, another universe perhaps, that exists beyond what we can see? This idea of influences from beyond adds a thrilling layer to our understanding of the cosmos. If these interactions are real, then we're not just isolated in our universe. We're connected to a greater web of realities, a cosmic neighborhood we can't see but might be able to sense. It's a bit like living in an apartment and hearing faint noises from the units next to you. You can't see your neighbors, but you know they're there, existing just beyond the walls. And yet, with all these theories, one thing remains constant: we're limited by the edge of what we can observe. No matter how powerful our telescopes become, we can only see as far as the speed of light allows. This cosmic light horizon acts as a boundary, beyond which we have no information, no clues, no way of knowing what's there. It's a bit like being on a ship in the middle of the ocean, with mist surrounding you in every direction. You know there's something beyond the mist, but you can't see it. You can only imagine. That limitation is what makes the concept of cosmic boundaries so tantalizing. If we could somehow surpass this horizon, we might find answers to some of our biggest questions about the universe. But it's unlikely we'll ever be able to see beyond this boundary in a conventional sense. Even if we develop technology that allows us to travel vast distances, the expansion of the universe itself is always working against us. The farther away something is, the faster it moves away from us, and at a certain point, it moves faster than light itself. This creates a sort of cosmic escape velocity that forever places parts of the universe out of reach. Some physicists argue that these boundaries aren't just physical but also metaphysical. Perhaps there's a limit to what we can know, an inherent boundary in our ability to perceive or understand reality. After all, our understanding of the universe is filtered through the lens of human cognition. Our brains, shaped by evolution, may simply be incapable of grasping certain aspects of reality. It's a humbling thought that there may be truths about the cosmos that are fundamentally beyond our reach. And then, there's the mystery of time itself, which adds another layer to this boundary. When we look out into space, we're actually looking back in time. The light from distant stars and galaxies takes millions or even billions of years to reach us, so we're seeing these objects as they were in the past. In a way, this means that the edge of the observable universe is also an edge in time. Beyond it lies not only a spatial boundary but also a temporal one. What we can observe is a snapshot of the universe's past, a frozen image of cosmic history, while the present and future of those distant regions are hidden from us. This raises the profound question of whether time itself might work differently beyond our observable universe. Could there be regions where time flows in a different direction, or where cause and effect operate differently? Some theories propose that time, as we know it, may be a property unique to our universe, arising from its specific physical conditions. If there are other universes beyond our own, it's possible they don't experience time in the same way we do. Perhaps they have their own unique versions of time, or perhaps they exist in a kind of timeless state that we can't fully comprehend. The possibility of timeless realms is an idea, but it's a serious consideration for some physicists. They suggest that what we perceive as time is just a dimension within a larger framework, and that if we could step outside of time, we would see the entire history of the universe laid out in front of us, past, present, and future coexisting in a single, unchanging tableau. In this view, the flow of time is an illusion created by our limited perspective, much like how we perceive a river flowing when, in reality, it's all one continuous body of water. If time itself is just one of many dimensions, then the boundaries of the universe might be far stranger than we ever imagined. They might not be fixed, static walls but rather flexible, shifting regions that we can't comprehend with our current understanding of physics. These boundaries could even be shaped by our own consciousness, in a way, meaning that what we perceive as the edge of the universe is just a construct of the human mind, a necessary limit imposed by the way we process reality. Thinking about the edge of the universe, what lies beyond it, and how it might differ from everything we know stretches the boundaries of human imagination. Perhaps the biggest mystery isn't the universe itself but the fact that we're capable of pondering it, questioning it, and pushing to understand it. We're creatures of the universe, built from the same matter and energy that fill the cosmos, yet we have the unique ability to look up and ask, "What's out there?" And maybe, in the end, it's this journey of exploration and wonder that truly defines us. We may never reach the edge of the universe, we may never know what lies beyond, but the act of trying, of striving to know, is part of what makes us human. In a universe filled with mysteries, that sense of curiosity, that urge to explore, might just be the most profound thing of all. Imagine, for a moment, standing at the very edge of the observable universe, if such a place even exists in any real sense. In reality, there's no edge, like a cliff we might walk up to and look over. Space doesn't just stop, it doesn't hit a wall and fall off into some void. Instead, the universe keeps expanding, growing faster and faster as we speak. It's almost as if the fabric of space itself is pulling away, stretching out infinitely, which leaves us wondering, what exactly is it expanding into? Or if the universe isn't expanding into something, then how do we even make sense of this growth? One way to think of this is by imagining the universe as the surface of a balloon being inflated. As it expands, every point on that surface gets farther away from every other point, but there's no edge to the surface itself. The universe is expanding in a similar way, but in 3 dimensions rather than just 2. It's a strange idea, one that can make your head spin if you think about it for too long. And while this balloon analogy helps to visualize the concept, it still doesn't answer the question of what, if anything, lies beyond that expanding boundary. Some scientists suggest that, quite simply, there may be nothing beyond it. Not in the sense of an empty void, but in the sense that there's no space, time, or even physical laws as we know them. This concept is hard to grasp because we're used to thinking of space as something that exists independently, like a container we live in. But what if space and time are only properties of our universe? Beyond them, there might be, well, truly nothing. On the other hand, if there's something beyond our observable universe, it may be another universe altogether. Here's where the multiverse theory takes center stage. This idea proposes that our universe is one of countless others, each with its own separate space, time, and physical laws. Imagine an endless landscape filled with an infinite number of bubble universes, each one isolated yet possibly connected through some mysterious, unseen medium. These universes might be born in their own big bangs, or emerge from some cosmic landscape we don't yet understand. Now, the idea of the multiverse isn't just science fiction. It's actually grounded in some areas of theoretical physics and cosmology. For instance, in quantum mechanics, there's a theory known as the many worlds interpretation. This theory suggests that every possible outcome of a quantum event actually happens, creating a branching network of parallel realities. According to this view, there might be other versions of our universe where events have played out differently, where another version of you might have made different choices, leading to a completely different life. And while the many worlds interpretation doesn't directly imply the existence of parallel universes on a grand cosmic scale, it opens up the tantalizing possibility that reality itself is far more layered and complex than we can observe. Another angle on the multiverse concept comes from string theory, which is an attempt to explain the fundamental structure of the universe. String theory suggests that all particles are actually tiny, vibrating strings, and that these strings exist in a universe with more than the familiar 3 dimensions of space and 1 of time. In fact, some versions of string theory propose that there are as many as 11 dimensions. These extra dimensions could potentially allow for other universes, each occupying a different dimension, beyond our perceptual reach. These universes might be so close to ours that they're only separated by an incredibly tiny distance in these extra dimensions, so close, and yet forever out of reach. Now, if you think that's mind-bending, consider another possibility. What if our entire universe exists on a kind of membrane, floating within a higher dimensional space? This is known as the brane theory, and it suggests that our universe is just one of many branes existing in a larger, multidimensional space. Other universes could be floating alongside ours, separated only by a tiny distance in dimensions we can't perceive. If these branes occasionally collide, the impact could trigger Big Bang-like events, creating new universes in the process. Imagine that for a moment, our universe, floating alongside countless others in an incomprehensible ocean of higher dimensions. The vastness of this concept is overwhelming. We may be part of a multiverse, where universes are created and destroyed in an endless cycle, a process that goes on eternally, without beginning or end. The sheer scale of it all, and the idea that our universe might be just one tiny blip in a much grander cosmic structure, makes our daily lives feel almost laughably small. And yet, knowing that we're just a piece of a much larger puzzle doesn't diminish our existence. If anything, it makes the mystery even more profound. In this grand picture, some physicists speculate that there could even be pathways connecting different universes. These pathways, often referred to as wormholes, could theoretically link different regions of space-time, or even different universes. In science fiction, wormholes are often depicted as shortcuts through space, allowing instant travel across vast distances. But if the multiverse theory is correct, wormholes might also connect our universe to others. Imagine stepping through a portal and finding yourself in an entirely different reality, with its own stars, galaxies, and perhaps even its own version of life. While wormholes remain speculative and have yet to be observed, they represent a tantalizing possibility for those who dream of exploring beyond our cosmic boundaries. It's worth noting, however, that even if other universes do exist, they might be fundamentally inaccessible to us. The very nature of the multiverse might make direct interaction impossible. Each universe could be sealed off from others, with no way of crossing the boundaries between them. In that sense, the multiverse might remain forever beyond our reach, a tantalizing idea we can only speculate about, without ever experiencing firsthand. As we probe these mysteries, we're also forced to confront the limitations of our own understanding. The human brain is wired to think in certain ways, to make sense of the physical world we experience. But concepts like multiple dimensions, parallel universes, and infinite space challenge us to think beyond those limitations. It's possible that there are aspects of the universe, or multiverse, that we'll never be able to fully grasp, simply because our minds aren't equipped to understand them. At the same time, the pursuit of these ideas is what drives science forward. Even if we can never know for certain what lies beyond our observable universe, the act of wondering, theorizing, and exploring pushes us to expand the boundaries of human knowledge. It's a journey that may never have a final destination, but it's one that enriches our understanding of existence in ways we can barely comprehend. The question of what lies beyond the edge of the universe might be less about finding definitive answers and more about embracing the unknown. The cosmos is a vast, mysterious place, filled with wonders we're only beginning to understand. And as long as we continue to ask questions, to look beyond what we can see, we remain connected to that mystery. The universe may keep its secrets, but our curiosity, our desire to know, will always keep us reaching for the stars. As we continue to probe the edges of our understanding, we come up against the vastness of what we don't know. When we talk about the edge of the observable universe, we're really talking about how far light has traveled since the beginning of time, or roughly 13.8 billion years. This doesn't mean the universe is 13.8 billion light-years across, though. Because of the expansion of space, the observable universe is actually around 93 billion light-years in diameter, a mind-boggling distance that's hard to picture in any concrete way. This observable limit is defined by the cosmic light horizon. Light from beyond this horizon simply hasn't had enough time to reach us yet, no matter how fast it's been traveling. The universe could be far, far larger than what we can observe, or it might even be infinite. But here's where things get tricky. Even if the universe is infinite in size, that doesn't mean everything beyond the observable horizon is knowable. What lies beyond that boundary could remain a complete mystery, forever hidden from us because of the fundamental nature of light, space, and time. Some physicists even suggest that the universe beyond our observable horizon might be radically different from what we see. The laws of physics that hold true here may not apply out there. Imagine a realm where gravity works differently, or where the basic particles that make up matter are totally unlike the ones we're familiar with. In this sense, the edge of the observable universe might mark not just a physical boundary, but also a boundary of knowledge itself. However, some fascinating theories suggest ways that information might leak across these boundaries. One possibility involves cosmic background radiation, the faint afterglow of the Big Bang, which bathes the entire universe. Scientists have mapped this radiation in exquisite detail, and they've discovered some curious anomalies that don't quite fit our understanding of how the universe should look. These anomalies, patterns and hot or cold spots that seem out of place, could be hints that there are influences on our universe from something beyond. Some theorists propose that these strange spots could be imprints left by other universes colliding with ours, like bubbles bumping into each other in a cosmic foam. If this idea is correct, then our universe might have neighbors, each one a separate bubble with its own unique properties. These collisions would be incredibly rare, but if they did happen, they might leave subtle marks that we can observe. Another theory, known as eternal inflation, suggests that our universe is part of an ongoing process in which new, pocket, universes are constantly being created. This theory emerged from the inflationary model of the early universe, which describes a period of rapid expansion that occurred just after the Big Bang. According to eternal inflation, this expansion didn't stop, but instead continues in some regions of space, giving rise to an infinite number of universes. Our own universe would be just one of these pockets, each one with its own distinct laws and properties. The concept of eternal inflation leads to some truly mind-bending possibilities. If new universes are constantly being created, then perhaps every possible version of reality exists somewhere in this vast multiverse. In one universe, conditions might allow for completely alien forms of life to emerge. In another, stars might not even form at all. The diversity of possibilities is beyond anything we could ever catalog or understand fully. And yet this theory suggests that the multiverse is constantly growing, an endless, dynamic process that may never reach a final state. As strange as it may sound, some scientists believe that studying the quantum behavior of particles here on Earth could give us clues about the multiverse. Quantum mechanics, which deals with the behavior of particles on the smallest scales, often defies our everyday logic. Particles can exist in multiple states at once, or become entangled, affecting each other instantly across vast distances. Some interpretations of quantum mechanics suggest that these strange properties could be evidence of connections between different universes. For example, in the many worlds interpretation of quantum mechanics, every decision creates a split, with each possible outcome playing out in a separate reality. If this interpretation is correct, then the universe is constantly branching into countless versions, each one slightly different from the last. While these branches wouldn't represent separate universes in the traditional sense, they suggest that reality is far more complex and layered than it appears. The question of what lies beyond the observable universe doesn't just invite us to think about space, but about time as well. Time is something we usually think of as linear, a sequence of moments that flows from past to future. But on the grandest scales, time might behave in ways that we can barely imagine. Some physicists have proposed that time itself might be an illusion, a concept that arises from the way we perceive the universe rather than something fundamental to its nature. In this view, the universe could exist as a block of space-time, with every moment existing simultaneously. Our perception of time passing might be just that, a perception, a byproduct of consciousness rather than a fundamental property of reality. If time is an illusion, then what we see as the edge of the universe could also be an illusion. The universe might be a single, timeless entity, with all of space and time existing in a fixed state that we can only perceive in fragments. As if all of this weren't complex enough, there's also the question of dark energy, the mysterious force that seems to be driving the expansion of the universe. Dark energy is one of the most profound mysteries in cosmology. We know that it makes up about 68% of the universe, but beyond that, we know very little about it. Some scientists suggest that dark energy might actually be a property of space itself, something that pushes galaxies apart. Others think it might represent a kind of fifth force that we don't yet understand. If dark energy is a property of space, then as the universe expands, it creates more space, and thus more dark energy. This creates a runaway effect, where the universe expands faster and faster, accelerating toward an unknown future. Some theories even suggest that this acceleration could eventually tear the universe apart in a big rip, where every atom, galaxy, and star is pulled apart by the relentless force of dark energy. Alternatively, the universe could reach a point where it stops expanding and begins to contract, collapsing back in on itself in a big crunch. Either of these scenarios would lead to the end of our universe as we know it, but they also raise the tantalizing question of what might come after. If the universe ends in a big crunch, could it then rebound in another big bang, creating a new universe in the process? Some cosmologists propose that the universe might go through an endless cycle of expansions and contractions, a concept known as the cyclic model. In this view, each cycle of the universe is like a new chapter in a never-ending story, a grand cosmic rhythm that has no beginning or end. These ideas about the end of the universe, and what might come after, also tie back into the concept of the multiverse. If new universes can arise from collapsing ones, then there could be an infinite chain of universes stretching back and forward in time. Each universe could give rise to the next, with each one slightly different from the last. In this way, the multiverse isn't just a collection of parallel universes existing side by side, but an eternal sequence of universes, each one building on the legacy of the last. Thinking about the edge of the universe, the multiverse, and the nature of time challenges us to confront our place in the cosmos. Are we part of a single, finite universe, or just one universe in an endless sea of possibilities? Are we on the brink of discovering something about our reality that will completely change our understanding of existence? Or are we destined to remain forever in the dark, our knowledge limited by the boundaries of what we can observe? The mysteries of the universe are humbling. They remind us of how small we are in the grand scheme of things, and yet they also inspire a deep sense of wonder. The quest to understand what lies beyond the observable universe is as much a journey of imagination as it is of science. It challenges us to think beyond what we know, to question everything we assume about reality, and to embrace the mystery of existence with open minds. The search for answers might be the most important part of the mystery. It's the act of wondering, of reaching beyond what we can see, that brings us closer to understanding our place in the cosmos. And as long as we continue to explore, to ask questions, and to push the boundaries of knowledge, we remain connected to the vast and mysterious universe we call home. As we venture deeper into the unknown, one thing becomes clear: our understanding of the universe is constantly evolving. We've come so far, yet every answer we uncover often leads to more questions. As scientists continue to gather data from deep space and explore new ways of observing the cosmos, more theories will arise about what exists beyond the observable universe. In this search, one area that continues to pique our curiosity is the concept of space-time itself. Space and time are usually treated as separate entities in everyday life. We experience time as something that flows forward, one second after another, and space as the three-dimensional realm in which we move. But the theory of relativity, proposed by Albert Einstein, showed that space and time are interconnected, forming a four-dimensional continuum known as space-time. This relationship between space and time is far more than just a conceptual idea. It's fundamental to the way the universe works. Massive objects, such as planets and stars, bend space-time around them, creating what we perceive as gravity. This bending of space-time is not just a theoretical concept. It has been observed in many ways, from the orbits of planets to the bending of light around distant galaxies. The famous experiment during a solar eclipse in 1919 confirmed Einstein's theory, showing that light from distant stars bent around the sun in exactly the way he predicted. But as we look further into the mysteries of the universe, we realize that space-time itself might not be as rigid as it seems. Some theories suggest that space-time might be quantized, meaning it is made up of discrete units, similar to how matter is composed of atoms. If this is the case, then the fabric of space-time could have an underlying structure that we can't yet observe. And this could have profound implications for our understanding of what lies beyond the edge of the observable universe. The idea that space-time could be granular, composed of tiny chunks, is explored in the field of quantum gravity. This area of research attempts to combine the principles of quantum mechanics, which governs the behavior of particles on the smallest scales, with general relativity, which describes the behavior of massive objects on the grand scale of the cosmos. A complete theory of quantum gravity could not only help us understand the nature of space-time but also offer insights into the very beginning of the universe itself, the so-called Big Bang. One intriguing aspect of quantum gravity is the potential role of black holes. These mysterious regions of space, where gravity is so strong that nothing, not even light, can escape, might hold the key to understanding space-time's deepest secrets. Some theorists propose that black holes could serve as gateways to other regions of the universe, or even other universes altogether. This idea is closely related to the concept of wormholes, hypothetical tunnels in space-time that could connect distant points in the universe or, in some cases, other universes. Wormholes are a popular subject in science fiction, but they are also taken seriously by physicists as a potential consequence of general relativity. A wormhole, if it exists, could allow for instantaneous travel between two far-flung regions of space. However, the practical realities of such a journey are, for now, far beyond our capabilities. The biggest hurdle is that wormholes, if they do exist, would likely be incredibly unstable and collapse almost immediately upon forming. This makes it very difficult to imagine how they could be used for travel, even if they are a genuine feature of the universe. Yet, the possibility that wormholes might exist at all suggests that space and time might not be as solid and unchanging as we perceive them. If we could somehow manipulate or control space-time, we might be able to open windows into other parts of the universe, or even into other universes entirely. This idea brings us back to the concept of the multiverse, where our universe is just one of many, potentially with its own rules, properties, and realities. Some researchers have suggested that black holes could act as bridges between different universes, with the singularities at their centers serving as the doorway. This is a speculative idea, and there's currently no direct evidence to support it. But it's a concept that has sparked much debate and exploration in theoretical physics. If black holes do serve as connections to other universes, then the edge of our observable universe might not be the end of reality at all. It could just be a temporary boundary, a limit we've reached because of the way light and information travel. In another intriguing twist, some scientists propose that the concept of the edge of the universe might not even make sense in the way we understand it. One of the peculiar aspects of our universe is its expansion. Since the Big Bang, the universe has been expanding at an accelerating rate, and this expansion seems to be continuing today. This raises the question, if the universe is expanding, what is it expanding into? Most people would think that space itself is expanding, but what does that mean for what's beyond it? According to some models of cosmology, the universe may not be expanding into anything at all. Instead, the fabric of space itself is stretching, creating more space between galaxies. In this view, the universe has no edge in the conventional sense. There's no boundary or outer region beyond which things end. It's just that the further you look, the more space you see, stretching out indefinitely. The question of what lies beyond the observable universe is thus tied to deep questions about the nature of space, time, and reality itself. Whether it's the multiverse, wormholes, the behavior of quantum gravity, or the nature of spacetime, each theory offers a fascinating glimpse into the possibilities of what could exist beyond our current understanding. As we continue to explore these mysteries, one thing is clear: we are just scratching the surface of what could be one of the greatest discoveries in the history of human thought. Whether we'll ever uncover the true nature of the universe's edge, or whether it's even possible to comprehend such an expansive concept, is something that remains to be seen. But as long as we keep asking questions, pushing boundaries, and seeking answers, the journey into the unknown will continue to captivate us. It's a journey that may ultimately take us beyond the stars, beyond the observable universe, and into realms of existence that are beyond imagination. As we consider the infinite possibilities of what might lie beyond the observable universe, it's important to remember that our understanding of space and time is constantly evolving. New theories and discoveries push the boundaries of what we know and help us imagine scenarios that were once thought impossible. The nature of the observable universe and the space beyond it is not something that will be easily solved, but the process of discovery is invaluable. Each step forward opens new doors to questions we've yet to even think of. A crucial aspect of this journey is the very concept of the observable universe. When we look out into the cosmos, we're not simply observing a vast expanse. What we see is limited by the speed of light and the finite amount of time the universe has existed. Light from the farthest reaches of the universe has only had a finite amount of time to reach us, meaning we can only observe the parts of the universe that are within this light cone. The observable universe is essentially a sphere around us, defined by the distance that light has been able to travel since the Big Bang. This limitation, however, does not mean that the universe ends at the edge of what we can see. It simply means that the rest of the universe is beyond our current ability to observe. The true extent of the universe could be much larger than what we can perceive. Some scientists even argue that the observable universe is only a tiny fraction of the total universe, and that the real universe might extend far beyond our current observational limits. In this view, the edge of the observable universe is not an actual boundary but a horizon, a limit to how far our instruments can detect. But what happens beyond this horizon? Could there be regions of space that are radically different from what we know? Some cosmological models suggest that regions beyond our observable universe could contain structures, forces, or even laws of physics that are completely unfamiliar. These far-flung regions could have completely different physical properties, making them unrecognizable or even incomprehensible from the perspective of our own universe. There's also the intriguing idea that space-time itself could be curved or warped on the grandest scales, creating regions where the normal laws of physics break down. In this view, the universe might not have an edge at all, but could be curved in such a way that it loops back on itself, much like the surface of a sphere. If the universe is indeed curved in this way, then traveling in one direction for long enough could eventually bring you back to your starting point, making the concept of an edge irrelevant. This concept challenges our understanding of what it means for something to have an edge or boundary, forcing us to rethink the very nature of the universe. The multiverse theory is another captivating idea that pushes the limits of what we can imagine. According to this theory, our universe may be just one of many in a vast multiverse. Each of these universes could have different physical constants, laws, or even dimensions, leading to entirely distinct realities. Some versions of the multiverse theory suggest that these universes could interact with one another, or that they could exist in parallel, hidden just beyond the reach of our perception. The multiverse is a highly speculative idea, and it's still a topic of intense debate among scientists. Some argue that the multiverse is an untestable hypothesis, and therefore not a valid scientific theory. Others, however, believe that the multiverse could be a natural consequence of certain physical theories, such as string theory or the inflationary model of the universe. In either case, the multiverse offers a tantalizing glimpse into what might exist beyond the confines of our observable universe. One version of the multiverse theory, known as the bubble multiverse, posits that different regions of space could undergo their own versions of cosmic inflation, creating separate bubbles of universes, each with its own distinct properties. These universes could be completely isolated from one another, existing in parallel with no way to interact. If this is the case, then the observable universe is simply one bubble in an infinite sea of universes, with no boundary to define where one ends and another begins. In this scenario, the idea of an edge to the universe becomes meaningless. Instead, we would live in a universe that is part of an endless, ever-expanding multiverse, where each universe has its own set of rules and laws. This would mean that what we see as the edge of the observable universe is just a small part of an infinite, ongoing process of cosmic evolution. As we explore these fascinating ideas, one thing becomes clear: the search for what lies beyond the observable universe is not just about pushing the boundaries of our observational technology. It's also about challenging the very way we think about the cosmos. Our conventional understanding of space, time, and reality is rooted in a set of assumptions that have served us well for centuries. But as our instruments improve and our theories evolve, it's becoming increasingly clear that the universe is much stranger and more complex than we could have ever imagined. There's also the possibility that the universe, in some sense, has no edge at all. According to certain models of cosmology, the universe may be infinite and unbounded. If the universe is truly infinite, then there would be no edge to reach. It would simply stretch on forever in all directions. In this view, the observable universe is just a small patch of a much larger, infinite cosmos, and the universe itself would have no end. This idea of an infinite universe also raises questions about the nature of space-time. If the universe is infinite, then space-time itself must be infinite as well, extending infinitely in all directions. This concept challenges our understanding of the beginning of the universe. If the universe is infinite, how did it all start? Was there ever a beginning, or has the universe always existed in some form? Some cosmologists propose that the universe could be infinite in time as well as space, suggesting that time itself could stretch infinitely in both directions. In this view, the universe has no beginning or end, and it simply exists as an eternal process. This idea is deeply philosophical and difficult to test, but it opens up fascinating questions about the nature of reality itself. In the end, the question of what lies beyond the edge of the universe is not just a scientific one, it's a philosophical question that forces us to confront the limits of our knowledge and imagination. Whether it's the multiverse, infinite space-time, or entirely new dimensions of existence, the journey to answer this question will continue to challenge our understanding of the universe for generations to come. While we may never be able to peer beyond the observable universe with absolute certainty, the questions we ask, the theories we propose, and the discoveries we make will shape the future of cosmic exploration. As we continue to push the boundaries of our understanding, we move ever closer to unraveling the most profound mysteries of the cosmos. As we continue to probe deeper into the nature of space and time, it's important to reflect on how much we've already achieved. The observable universe is vast, immeasurably so, but it's just a glimpse of what could exist beyond our understanding. While much of what lies beyond the edge remains speculation, theories of the multiverse, cosmic inflation, and the potential for hidden dimensions present a landscape that stretches the limits of our imagination. One of the primary reasons it's so difficult to conceptualize what might be beyond the observable universe is the nature of light and time itself. The speed of light, which is roughly 299,792 kilometers per second, is often seen as the ultimate speed limit in the universe. Because light travels at this speed, Any object that is farther away than a certain distance will not have its light reach us in time, even if it has been emitting light since the Big Bang. This is why the observable universe is limited. Light from the farthest galaxies has only had a finite amount of time to travel to us, meaning we cannot see beyond a certain point. This limitation introduces the concept of cosmic horizons, essentially the boundary beyond which we cannot observe or receive information. This is a critical part of understanding what lies beyond the observable universe because it presents the notion that the universe may continue far beyond the regions we can see. Our cosmic horizon, while limiting our observation, doesn't define the actual extent of the universe itself. Beyond the observable universe, new galaxies, star systems, and potentially new realms of reality may exist. The challenge lies in the fact that we can never directly observe these regions. No matter how advanced our technology becomes, light from these distant corners may never reach us. This doesn't mean that the universe simply stops at this boundary, far from it. The universe could be infinite, with regions beyond our current observational limits that are just waiting to be discovered, though their very nature may be fundamentally unreachable due to the limitations of light speed. In thinking about the multiverse theory, one of the more radical possibilities emerges: the idea that the observable universe is just one bubble in a much larger cosmic foam. This bubble could be part of a larger, ever-expanding multiverse, where each bubble represents a different universe with its own set of physical laws and constants. This concept is a direct result of the inflationary model of the universe, which proposes that the universe underwent a rapid expansion during its first moments, stretching far beyond the regions we can observe today. One fascinating aspect of the multiverse is that each bubble could be completely isolated from one another, meaning that the laws of physics that govern one bubble might be entirely different from those in another. This could mean that what we perceive as the fundamental constants of nature, such as the speed of light or the strength of gravity, could vary across different universes. The possibility of universes with entirely different physical properties opens up the door to an almost infinite number of potential realities, each with its own set of rules, behaviors, and phenomena. This radical departure from traditional cosmological thinking forces us to reconsider how we understand the very nature of existence. If the multiverse theory holds any merit, then we may be living in a universe that's only one example of many, a mere blip in an infinite, multiversal sea. For those who contemplate such theories, it's both exciting and humbling to think about how much we might still not know, how many universes are out there, existing beyond our understanding and imagination, each a mirror reflecting a different set of possibilities. But as compelling as the multiverse theory may be, it does not come without its challenges. Some argue that it's inherently untestable, which makes it difficult to regard as a fully scientific theory. Since we have no way to directly observe other universes or interact with them, it's difficult to confirm their existence using traditional scientific methods. This raises important questions about the nature of scientific inquiry itself. Can something be considered science if it cannot be observed or tested? Theories like the multiverse stretch the boundaries of what we consider to be science, forcing us to rethink the relationship between observation and knowledge. Beyond the multiverse, there are other potential explanations for what exists beyond the observable universe. For example, some physicists speculate that the universe could be part of a higher dimensional space. In such a model, the three spatial dimensions that we're familiar with, length, width, and height, might not be the only dimensions that exist. There could be additional spatial dimensions, beyond our ability to perceive them, influencing the behavior of space-time. One theory that involves higher dimensional space is string theory. This theory posits that the fundamental particles that make up the universe are not point-like objects, but instead tiny vibrating strings. These strings could exist in higher dimensional space, meaning there are dimensions beyond the three we perceive. If this is true, then the true nature of the universe may be hidden in these extra dimensions, making the observable universe a mere shadow of a more complex, multidimensional reality. String theory suggests that our universe might be a three-dimensional brane, floating within a higher dimensional space. These higher dimensions could harbor other branes, each potentially containing its own universe. If this theory is correct, then what lies beyond the observable universe may not be an empty void, but rather the potential for entire new realms of existence, universes that are completely invisible to us, existing in parallel within the same higher dimensional space. The idea that there could be more dimensions than the three we're familiar with also invites questions about the very nature of gravity. In our three-dimensional universe, gravity is the weakest of the fundamental forces. However, in higher dimensional space, gravity might behave very differently. Some theories suggest that gravity might be much stronger in higher dimensions, and that the gravitational force we experience could be a result of the way it's spread out over the extra dimensions. This could also explain why gravity appears to be so weak compared to the other forces of nature, such as electromagnetism or the strong and weak nuclear forces. These theories of higher dimensional space and the multiverse challenge our very understanding of the nature of existence itself. They invite us to think beyond the limits of our own experience, to imagine a cosmos that is far more complex and expansive than we could have ever conceived. The idea that the observable universe is just one piece of a larger, multidimensional puzzle forces us to reconsider what is truly real, and how we define the limits of existence. In the end, the question of what lies beyond the observable universe is a profound and challenging one. While the theories we've discussed here, whether it's the multiverse, higher dimensional space, or an infinite universe, are all fascinating, none can be definitively proven or disproven at this stage. But that's part of what makes the quest for knowledge so exciting. The mysteries of the cosmos are vast and incomprehensible, and as we continue to explore, we'll undoubtedly encounter even more questions that challenge our understanding. But what we do know is this: the universe is far stranger, more complex, and more mysterious than we could ever have imagined. The edge of the observable universe is not a boundary in the traditional sense, it's just a horizon, a limit to what we can currently perceive. Beyond it lies the unknown, waiting for us to explore and discover. Whether through the lens of science, philosophy, or imagination, the journey to understand what lies beyond will continue to captivate and inspire us for generations to come. The mysteries surrounding the edge of the universe are vast, and as we venture further into the unknown, we are reminded that our understanding of space and time is constantly evolving. New discoveries, advancements in technology, and breakthroughs in theoretical physics all contribute to our ever-expanding view of the cosmos, but there is still so much we cannot yet comprehend. As we approach the boundaries of our knowledge, we must also ask ourselves, how much of this mysterious expanse will we ever be able to explore? The very nature of the observable universe suggests that we are only able to access a fraction of the true cosmos. What lies beyond these limits? Is it possible that our entire understanding of space, time, and reality is just one small part of a much grander, more intricate whole? One critical piece to this puzzle comes from the field of cosmology, where scientists have been grappling with the concept of cosmic inflation. This theory, proposed in the early 1980s, posits that in the very early moments of the universe's existence, space itself expanded exponentially in a fraction of a second. This sudden and dramatic expansion is thought to have shaped the large-scale structure of the universe, pushing distant regions far beyond our observational reach. Essentially, the observable universe, as vast as it is a mere snapshot of a much larger cosmos, which itself could extend endlessly. In the context of cosmic inflation, the universe didn't just expand from a single point into the space we now observe. It expanded in such a way that regions that are now far beyond our horizon may have been forever disconnected from us. This disconnection is a result of the speed at which space itself expanded, faster than the speed of light, effectively separating distant parts of the universe in a way that precludes any future communication between them. So, the observable universe is not just limited in space, but also in time, as we are witnessing only a fraction of the events and phenomena that have occurred in the farthest reaches of the cosmos. But what happens beyond these vast, unreachable regions? Some physicists propose that the expansion of the universe continues indefinitely, pushing galaxies and stars farther apart as time progresses. This means that the universe we know, with its billions of galaxies and countless stars, might eventually become so stretched out that it could appear empty. As distant galaxies move beyond our reach, and the energy in the universe spreads out, what will be left in the observable universe? Could we eventually find ourselves in a vast, dark, and lonely void, with the remnants of a universe that has spread too thin to support life or even light? Another fascinating aspect of the universe's edge is the possibility that it might not have an edge at all. The observable universe could simply be a part of an infinite, unbounded space. If this is the case, then the universe could stretch out forever in all directions, with no true end. While this idea is difficult to wrap our minds around, it challenges the traditional view of an edge or boundary that we instinctively imagine. In an infinite universe, there would be no edge to cross, no final destination to reach, just an unceasing, boundless cosmos extending infinitely in every direction. This concept of an infinite universe raises additional questions about the nature of space itself. Is space a fabric that continues to stretch indefinitely, or is there some underlying structure that dictates the ultimate limits of reality? The idea of an infinite universe suggests that we might be able to explore it forever, never encountering a true end, but rather an infinite series of new discoveries and challenges. In contrast to the notion of an infinite universe, some scientists entertain the idea of a finite universe. If the universe is finite, it would have a distinct edge or boundary. However, such a boundary would not necessarily be a physical edge that we could see or touch, but rather a curvature of space-time, where the fabric of the universe bends back on itself. This is similar to how the surface of a sphere doesn't have an edge. If you travel far enough in one direction, you eventually end up back where you started. The idea of a finite but unbounded universe is mind-boggling, as it challenges our everyday understanding of space. If the universe were finite, it might mean that the space we live in is like the surface of a hypersphere, a higher dimensional shape. This means that if we could somehow travel far enough, we might come back to the point where we began, but on a cosmic scale. Though this is a difficult concept to grasp, it remains a possible solution to the mysteries of the universe's edge. Beyond these traditional models, we must also consider the potential for hidden dimensions. String theory, for example, suggests that the universe may contain extra spatial dimensions beyond the familiar three. These extra dimensions could be curled up in such a way that they are too small to detect with current instruments. These dimensions could have profound implications for the structure of the universe and what lies beyond our observable reality. Perhaps the edge of the universe is merely the boundary of our perception, beyond which lie higher dimensions of space and time that we are yet to comprehend. The existence of higher dimensions could provide a framework for understanding phenomena that currently elude us. For instance, the mysteries of gravity, dark matter, and dark energy might be explained in part by the presence of hidden dimensions. These dimensions might influence the behavior of the universe in subtle ways, affecting everything from the formation of galaxies to the very fabric of space-time itself. This brings us to the intriguing possibility of a multiverse. If there are higher dimensions of space that we cannot observe directly, could it be that there are entire universes existing within these dimensions, each with its own unique properties and laws of physics? The multiverse theory suggests that the observable universe is just one bubble in a vast sea of other universes, each with different conditions and histories. These universes could be vastly different from our own, with varying numbers of dimensions, forces, and particles. If such a multiverse exists, what does it mean for the nature of reality? One possibility is that the universes in the multiverse could be connected in ways that are not immediately apparent. Just as the visible universe is connected through the fabric of space-time, these other universes could be connected through higher dimensional space. This would mean that the boundary of the observable universe is not the true edge of reality. It's just one part of a much larger, interconnected cosmos. As we continue to explore these concepts, it's important to recognize that our understanding of the universe's edge is still very much in its infancy. We've made incredible strides in understanding the universe's expansion, its structure, and the forces that govern it, but there's still so much we don't know. The edge of the universe represents a frontier, a place where our current knowledge ends and the unknown begins. It's a place of infinite possibility, where every answer leads to new questions and deeper mysteries. What lies beyond the observable universe? The answer, perhaps, is that we can never fully know. We may glimpse hints of the vastness beyond, but the true nature of the universe's edge may forever remain a mystery. Yet, as we continue to push the boundaries of our knowledge, we can be sure that the journey to explore the unknown will never cease. With each new discovery, we come closer to understanding our place in this vast and awe-inspiring cosmos. And while we may never reach the edge, or truly understand what lies beyond it, the quest itself is what defines us. The search for answers, the desire to know the unknown, is what drives science, exploration, and discovery. It is this insatiable curiosity that will continue to propel humanity forward, uncovering the secrets of the universe, one step at a time. As we look further into the mysteries surrounding the edge of the universe, we must consider the nature of the forces that govern this vast, expanding cosmos. In particular, the concepts of dark matter and dark energy have captured the attention of scientists and astronomers, as they hold the key to understanding the true structure of the universe and its continued expansion. While these phenomena are still largely enigmatic, they offer us tantalizing glimpses into the universe's deeper workings, particularly when considering the edge and what lies beyond it. Dark matter, a substance that doesn't emit or interact with electromagnetic radiation like ordinary matter, makes up roughly 27% of the universe's mass energy content. While it remains invisible and undetectable through conventional means, scientists have inferred its existence due to its gravitational effects on visible matter. Dark matter plays a critical role in the formation of galaxies, acting as a scaffolding upon which visible matter can cluster, thus influencing the large-scale structure of the universe. In the context of the edge of the universe, dark matter could be an essential component of the cosmic fabric, shaping the way galaxies and clusters of galaxies are distributed across the cosmos. Its gravitational influence helps hold together large structures, and it could very well be a driving force in the dynamics of the universe at the largest scales. As we approach the furthest reaches of the observable universe, dark matter may continue to play a critical role in shaping how we perceive the cosmos, even in regions that lie beyond our observational limits. Then there's dark energy, an even more mysterious phenomenon that seems to be causing the acceleration of the universe's expansion. Unlike dark matter, which has a gravitational pull, dark energy seems to exert a repulsive force, pushing galaxies farther apart and accelerating the expansion of the universe. This mysterious energy makes up about 68% of the universe's total mass energy content. Though its exact nature is still unknown, dark energy is perhaps the most intriguing factor when considering the ultimate fate of the universe and what might exist at its farthest reaches. One of the most thought-provoking ideas about dark energy is that it could be a key component in understanding what lies beyond the observable universe. If dark energy continues to accelerate the expansion of the universe, we may find that distant galaxies move beyond our observational horizon at an increasing rate, effectively rendering them undetectable. This raises the question, will there ever be a time when the observable universe becomes so stretched that it's essentially isolated from the rest of the cosmos? And if so, what will the universe look like when we reach that point? This notion brings us back to the idea of cosmic boundaries. While we may imagine the universe as having a physical edge or boundary, it's equally possible that it has no edge at all. Space itself could be infinite, and the limits of our observable universe are simply a function of the finite speed of light and the expansion of the universe. The idea of an infinite universe means that there is no true, beyond, the observable universe, only regions that are beyond our ability to detect, due to the vast distances and time scales involved. If the universe is truly infinite, then what we see today may only be a tiny fraction of what exists out there. The vast majority of the universe would remain beyond our reach, forever out of sight, no matter how advanced our technology becomes. As we look deeper into the cosmos, we may come to realize that the edge of the universe is not something we can physically reach, it's an abstract concept, one that exists in our minds and our understanding of the universe's history and expansion. This raises another important question: could there be regions of the universe that exist outside of the observable universe, with entirely different physical laws or properties? One compelling idea comes from the theory of the multiverse. According to this theory, our universe could be just one of many universes that make up a larger multiverse. Each universe in the multiverse could have its own distinct set of physical laws, constants, and dimensions, creating an almost infinite variety of possible realities. The idea of the multiverse offers a potential explanation for what lies beyond the observable universe, suggesting that there may be an entire sea of parallel universes, each with its own unique properties. If the multiverse theory is correct, then the edge of our universe might not be a physical boundary at all. Instead, it could be the limit of our observable universe, beyond which other universes exist in a vast, uncharted expanse. The possibility that our universe is just one bubble in a larger multiverse opens up exciting new possibilities for what could lie beyond the observable cosmos. Perhaps the observable universe is simply a small fragment of a much larger and more diverse multiverse, where different laws of physics govern other realities. However, the idea of the multiverse remains speculative, and there is currently no direct evidence to support it. Some argue that the multiverse is an untestable hypothesis and may never be provable through observation or experimentation. Yet, as our understanding of cosmology and quantum mechanics deepens, the notion of the multiverse may eventually provide the key to answering questions about the universe's edge and what exists beyond. While these concepts are fascinating and thought-provoking, they also highlight the limitations of our current understanding. As we push the boundaries of science and technology, we may uncover new ways to observe the universe that we never thought possible. New telescopes, advanced particle accelerators, and quantum computing could offer us unprecedented insights into the universe's deepest secrets, allowing us to peer further into the cosmos than ever before. But even with these advancements, there will always be a fundamental question that remains: will we ever be able to fully comprehend the true nature of the universe, and what lies beyond its limits? The search for answers to these questions is likely to continue for generations to come. As our knowledge of space and time expands, we may begin to understand more about the fundamental structure of the cosmos and its ultimate fate. Whether we ever reach the true edge of the universe, or if such a boundary even exists, remains to be seen. What is clear, however, is that the quest for knowledge, the desire to understand the mysteries of the cosmos, will never cease. Ultimately, the edge of the universe may not be a physical location or a concrete boundary, but rather a reflection of our own limitations as explorers of the cosmos. As we continue to probe the universe's deepest secrets, we may come to realize that the edge is not a place, but an ongoing journey, a journey that will take us ever further into the unknown, driven by the insatiable curiosity that has always defined humanity's pursuit of knowledge. The mysteries of the universe's edge, its vastness, and its potential for infinite discovery are not just questions about science. They are questions about who we are as a species and how we relate to the cosmos. In many ways, the edge of the universe represents the limits of human understanding, but it also represents the boundless potential of our imagination and our ability to dream of new frontiers. The answers may not come easily, but the pursuit of those answers will continue to inspire generations of scientists, philosophers, and dreamers alike, as we strive to understand what lies beyond. As we venture deeper into this enigmatic question of what lies beyond the observable universe, we must consider the role that the fabric of space-time itself plays in shaping our perception of the cosmos. Space-time, the four-dimensional continuum that combines the three dimensions of space with the one dimension of time, is not merely a static backdrop to the events of the universe. It is an active participant in shaping the structure and evolution of the cosmos. Einstein's theory of general relativity showed us that space-time is malleable, capable of being curved by the presence of mass and energy. This curvature is what we perceive as gravity, and it governs the movement of objects throughout the universe. When we think about the edge of the universe, we have to remember that space-time itself is expanding. The universe is not just a collection of galaxies moving through space. Space itself is stretching, carrying galaxies along with it. The more distant an object is, the faster it appears to move away from us due to this expansion. But what does this mean for the edge of the universe? In some sense, the edge is not a physical place at all, but a result of this ever-expanding fabric of space-time. As space itself expands, the distance between objects increases, and objects that were once within our observable universe may eventually slip beyond our observational horizon, never to be seen again. This is the result of the accelerated expansion driven by dark energy, the mysterious force that seems to be pushing the universe apart at an ever-increasing rate. The idea that the universe is expanding is not new, but it's still mind-boggling to consider the implications. When we talk about the edge of the universe, we're really talking about the limits of what we can observe. The observable universe is defined by the distance light can travel since the Big Bang, and that limit is constantly changing as the universe expands. But beyond this observable horizon, there's no way of knowing what exists. In theory, the universe could be infinite, extending far beyond the limits of our perception. And yet, because of the finite speed of light and the constant expansion of space, there's a point beyond which no information can reach us. This realization brings us to an intriguing concept called the cosmic horizon. The cosmic horizon is essentially the boundary, beyond which we can no longer receive light or any other signals. It is not a hard boundary, like the edge of a solid object, but rather a limit to our perception due to the expansion of space. Beyond this horizon, the light from distant galaxies is moving away from us faster than the speed of light, meaning that it can never reach us, even if we wait for billions of years. In this sense, the universe has no edge in the traditional sense, but rather a horizon that continually shifts as the universe evolves. But even if we cannot observe these distant regions of the universe, that doesn't mean they don't exist. One of the most tantalizing possibilities in cosmology is that the universe extends far beyond the observable horizon, and that beyond what we can see, there could be entirely different structures, galaxies, and even entire regions of spacetime that behave in ways we cannot yet imagine. This concept leads to a question that has puzzled scientists and philosophers alike. If we could somehow cross the cosmic horizon, what would we find on the other side? The notion of crossing the cosmic horizon brings us to another intriguing idea that relates to the edge of the universe: the idea of parallel universes and alternate realities. If the universe is truly infinite, or if it exists within a multiverse, then it's possible that beyond our observable universe, there are entire other universes with different physical laws, properties, and even dimensions of space and time. Some theories suggest that these parallel universes could be radically different from our own, with entirely different conditions, histories, and even forms of life. If these parallel universes exist, they would lie beyond the observable limits of our own universe, possibly forever out of reach. One of the most well-known theories that touches on the possibility of parallel universes is the concept of the multiverse, which suggests that our universe is just one of many that exist in a larger cosmic landscape. There are several different versions of the multiverse hypothesis, each proposing a different mechanism by which multiple universes could coexist. For example, the bubble multiverse theory suggests that our universe is just one bubble within a vast multiverse of bubbles, each representing a separate universe with its own distinct laws of physics. In this model, the edge of our universe would not be the boundary of existence itself, but rather the limits of our observational reach within this vast multiverse. Another version of the multiverse theory is based on the idea of quantum mechanics, where the universe splits into multiple branches every time a decision or event occurs, creating a new universe for each possible outcome. In this framework, the edge of our universe is merely one of many possible branches, with countless other realities existing in parallel, each with its own unique history and evolution. This kind of multiverse theory suggests that the universe is not a single, monolithic entity, but rather a constantly branching tree of possibilities, with an infinite number of potential realities existing at the same time. The possibility of parallel universes raises fascinating questions about the nature of existence, and the ultimate fate of our own universe. If there are other universes beyond our own, what is their relationship to ours? Are they completely separate, or do they interact in ways we cannot yet detect? Could there be ways for us to observe, or even travel to these other universes? Or is the distance between them so vast that they remain forever beyond our reach? These are questions that remain unanswered, but they offer a tantalizing glimpse into the mysteries of what lies beyond the edge of our observable universe. Moreover, the concept of the multiverse challenges our understanding of the laws of physics. If different universes exist with different laws of physics, what does that mean for our own universe? Could our physical laws be just one set of many, each governing a separate universe? This would suggest that the constants we take for granted, such as the speed of light, the strength of gravity, and the nature of time itself, are not universal truths but rather local features of our particular universe. This opens up a whole new realm of possibilities for what the universe could be, and what could lie beyond the limits of our perception. The search for answers to these questions is ongoing, and it's likely that new discoveries and breakthroughs will continue to push the boundaries of what we know about the universe. As technology advances and our understanding of physics evolves, we may one day find ways to probe the furthest reaches of the cosmos, uncovering new insights into the true nature of space, time, and the edge of the universe. Until then, the mysteries of the universe's edge and what lies beyond will continue to captivate our imaginations and fuel our quest for knowledge. The edge of the universe is not a simple, physical boundary that we can pinpoint with a telescope or reach with a spaceship. Instead, it represents the limits of our knowledge and the vast expanse of space that stretches far beyond our ability to observe. Whether we're contemplating the nature of dark matter and dark energy, the possibility of a multiverse, or the very fabric of space-time itself, the edge of the universe challenges us to think beyond our current understanding and imagine what could lie beyond the horizon. As we continue our journey of exploration and discovery, we may never fully reach the edge of the universe, but in the process, we will undoubtedly uncover deeper truths about the cosmos, our place within it, and the mysteries that lie beyond our reach. The universe is vast, and its secrets are many. But the pursuit of those secrets is what drives us forward, propelling us into the unknown and inspiring us to ask the most fundamental questions about existence itself. As we continue to ponder the edge of the universe and the potential mysteries that lie beyond, it's essential to recognize that the very concept of beyond itself is fluid and heavily shaped by the limits of our current understanding of physics and cosmology. The universe, in its grandest form, is not something that can easily be boxed into neatly defined categories of space, time, and matter. These constructs are not constants but evolve based on the nature of the universe itself, which is always in flux. So, as we continue to explore, it's crucial to understand that the frontier we are examining is constantly shifting. One compelling question that naturally follows is how our current scientific instruments might one day offer glimpses beyond the boundaries we can see. Right now, much of our understanding of the universe is limited by the distance light can travel. Since light travels at a finite speed, and since space itself is expanding, some regions of the universe are effectively unreachable by the light emitted from them, even if we had the technology to travel at the speed of light. This expanding barrier is known as the cosmic event horizon, and it represents a point beyond which events and objects are forever beyond our observational capabilities. However, the human pursuit of understanding is never static. For example, advances in technology could potentially allow us to explore the cosmos in ways we haven't even imagined yet. Observations through different wavelengths of light, such as infrared or radio waves, could reveal previously hidden phenomena. Instruments like the James Webb Space Telescope, which can observe far beyond the reach of previous telescopes, have already begun to uncover secrets about distant galaxies and stars that were once thought to be unreachable. As technology improves, the ability to peer further into the universe and potentially beyond our current observational horizon will expand, reshaping our perception of the cosmos. Nevertheless, despite our technological advancements, there remains the possibility that some regions of the universe will always be out of reach. Theoretically, if the universe continues to expand at an accelerated rate due to dark energy, the distance between us and far-off galaxies will only increase, pushing them further out of reach. This means that, no matter how advanced our technology becomes, the universe could continually slip away from our grasp. In this way, the edge of the universe could remain just beyond our reach, forever elusive. Beyond the practical limits of observation, there are more profound theoretical questions to consider. What if the expansion of the universe is not only accelerating but is doing so in such a way that it causes new universes to form as others break apart or collapse? This idea, known as the eternal inflation theory, posits that the universe could undergo endless cycles of expansion and contraction, each time giving birth to new, separate universes in a process called cosmic budding. If this is true, then the observable universe might be just one bubble in an infinite cosmic ocean of universes, each with its own unique characteristics and laws of physics. This would mean that the concept of an edge is meaningless on the larger scale. There would be no edge, only an infinite continuum of creation and destruction, as universes are born and die in an eternal cycle. The possibility of an infinite number of universes raises another fascinating question. What kind of universes could exist beyond our own? We often imagine a universe as we know it, one governed by the familiar forces of gravity, electromagnetism, and the strong and weak nuclear forces. But what if other universes have entirely different sets of physical laws? What if they have different numbers of dimensions, different constants, or different forms of matter and energy? If such universes exist, they would remain hidden from our perception, with no way to observe or interact with them, and yet their existence would stretch the very boundaries of what we think is possible. In many of these theories, one universe might be radically different from another. In one, life might not be possible because of vastly different laws of physics. In another, the forces of nature might be stronger or weaker, making stars behave in ways we can't predict. These alternate realities, if they exist, would lie far beyond the boundaries of our observable universe, and the very idea that they exist challenges our traditional understanding of the cosmos. Yet, even within our own universe, there are unexplained mysteries that hint at the possibility of structures and phenomena far beyond our current comprehension. One example of this is the concept of dark matter and dark energy, mysterious forces that make up about 95% of the universe's total energy content but remain invisible and undetectable by conventional means. If we can barely perceive and understand the majority of what exists in our own universe, what might be lying just beyond the veil? These unknown forces and the vast, unobservable regions of space raise a number of questions about the very nature of the universe. Is the universe a closed system, with boundaries beyond which nothing exists? Or is it an open system, one that is connected to other universes or realms? This idea has been explored in various theories of the multiverse, including the brain theory, which suggests that our universe might exist as a three-dimensional brain within a higher dimensional space. If this is true, our universe could be just one of many brains floating in a higher dimensional space, each governed by different physical laws and separated by vast, unknown distances. While this idea is still theoretical and has not been proven, it suggests that our universe may not be the only one, and that there could be entire realms of existence far beyond our understanding. The question of what lies beyond the edge of the universe is not just a question of science but also of philosophy. It challenges our most fundamental assumptions about reality, existence, and the limits of human knowledge. As we stand on the threshold of discovery, we must ask ourselves, are we ready to embrace the vastness of the unknown, to accept that there may be things beyond our comprehension that we may never fully understand? Or will we continue to push forward, relentlessly seeking answers to the ultimate questions of existence, knowing that the answers we find may only raise more questions? The quest for knowledge is an eternal one, and while we may never fully answer the question of what lies beyond the observable universe, the search itself is what drives us to explore, to discover, and to understand the mysteries of the cosmos. Each new breakthrough, each new discovery, brings us one step closer to unlocking the secrets of the universe. Whether or not we ever reach the true edge of the universe, we will continue to explore the infinite expanse, always searching for the next great mystery to solve. The edge of the universe remains one of the most profound and intriguing mysteries of modern cosmology. As we continue to push the boundaries of our understanding and technology, we may one day uncover answers to questions we've only begun to ask. But even if the edge of the universe remains beyond our reach, the journey to uncover its secrets will undoubtedly shape our future and deepen our understanding of the cosmos, our place within it, and the nature of existence itself. As we continue to explore the boundary of the universe, we must also consider the role of space-time itself. This foundational element of physics governs the very structure of the cosmos, and affects how we think about the edge of the universe. Space-time, a concept introduced by Albert Einstein in his theory of relativity, is the fabric that combines the three dimensions of space with the one dimension of time, creating a four-dimensional continuum. The curvature of space-time is responsible for the phenomena we observe, like gravity, the motion of planets, and the bending of light. When we talk about the edge of the universe, we're often thinking of it in terms of distance. But space-time itself doesn't behave in simple, linear ways that our everyday experiences might lead us to believe. According to general relativity, space-time can stretch and warp, especially near massive objects like stars and black holes. This warping effect means that space-time doesn't have a definite, fixed edge. Instead, it's a continuously evolving structure, expanding and changing shape in response to the mass, energy, and momentum within it. The expansion of the universe, which began with the Big Bang, continues today. The universe isn't expanding into space, as we might imagine, rather, space itself is stretching. In this sense, the edge of the universe is not a physical boundary, but a limit on our ability to observe distant parts of the cosmos. As space continues to expand, galaxies are moving farther away from us, and light from these far-off galaxies is stretched, making them harder to detect. This expansion suggests that the universe may continue to grow, with galaxies moving further apart and leaving behind an ever-expanding gap that we can't observe. So, while there may be an observable limit, there is no definitive boundary in the traditional sense of an edge. Beyond the physical boundary, theories such as the multiverse continue to stir the imagination. The concept of the multiverse has emerged in various forms, including the many worlds interpretation of quantum mechanics, the theory of cosmic inflation, and the brain cosmology mentioned earlier. These theories suggest that our universe might be just one of many, each existing in a separate bubble or dimension, with its own unique set of physical laws. The existence of these other universes could explain some of the unanswered questions in our own universe, such as the fine-tuning of physical constants, or the apparent randomness of quantum events. But if these universes exist, they lie beyond the reach of our current observational tools, and we can only theorize about their nature. Perhaps one of the most intriguing ideas related to the edge of the universe involves the possibility of a boundary that isn't a physical edge at all but a point where the laws of physics as we understand them break down. The very nature of reality could change beyond a certain point, especially as we approach the singularity of a black hole, where space-time curves infinitely and our current understanding of physics no longer applies. In this sense, the edge of the universe could represent a point where our understanding of space, time, and matter reaches its limits. This notion has led to some speculation about the potential for a quantum boundary, where quantum effects might take precedence over classical ones, and where the fabric of space-time itself could behave in entirely unpredictable ways. Another area worth exploring is the idea of dark energy, which makes up about 68% of the universe. This mysterious force is driving the accelerated expansion of the universe, pushing galaxies further apart. Its exact nature remains a mystery, but it is believed to have a profound influence on the fate of the universe. Could dark energy play a role in the creation of new universes, or in the eventual death of our own? Some theories suggest that dark energy could eventually tear apart galaxies, stars, and even atoms in a big rip, an event that could mark the end of everything we know. If this occurs, the very concept of space-time might cease to exist in its current form, suggesting that the edge of the universe is not just a physical location but a point in time where the laws of the cosmos unravel. As we speculate about these ideas, it's important to recognize that many of them remain purely theoretical. Our current understanding of the universe is based on observations and experiments, but there are limits to what we can know with certainty. The very tools we use to study the universe, telescopes, particle accelerators, and mathematical models, are based on the assumptions and frameworks that we have developed over centuries of scientific inquiry. While these tools have led to remarkable discoveries, they may also have limitations that prevent us from seeing beyond certain points. For example, our understanding of gravity, which was revolutionized by Einstein's theory of general relativity, has yet to be reconciled with quantum mechanics, which governs the behavior of particles on the smallest scales. This divide has led to a search for a theory of quantum gravity, which would unify these two pillars of physics. If such a theory is discovered, it could offer new insights into the nature of the universe, including what might lie beyond the observable universe. The discovery of a unified theory of physics could provide the key to understanding the very fabric of reality and the true nature of space-time, including the possibility of other dimensions or even other universes. Despite these uncertainties, there is one thing we can be sure of: the search for answers will continue. As technology advances and our understanding of physics deepens, we may uncover new truths about the universe that challenge everything we thought we knew. The quest to understand what lies beyond the edge of the universe is not just a scientific endeavor but a philosophical one, pushing the boundaries of human curiosity and imagination. The more we learn about the cosmos, the more we realize how much we don't know. The edge of the universe, in many ways, represents the ultimate frontier, an area that may never be fully understood, yet beckons us to explore. It reminds us of the vastness of the unknown, and of the infinite possibilities that lie ahead. Even if we never reach the true edge of the universe, the journey itself will continue to inspire us, driving us to expand our knowledge and push the limits of human discovery. What lies beyond the universe is a question that may never be fully answered, but in asking it, we take part in the most human of endeavors: the search for meaning and understanding in a universe that is infinitely more complex than we could ever imagine. As we continue to explore the cosmos, we must remain open to the possibility that the answers we find may lead to even more profound mysteries, and that the edge of the universe might just be the beginning of an even greater journey. As we delve deeper into the mysteries that lie beyond the observable universe, we encounter more speculative ideas and theories that challenge not just our understanding of physics, but also our perception of reality itself. These theories, though they may seem outlandish, push the boundaries of human thought and imagination. They ask profound questions about the nature of existence, the structure of the cosmos, and the possibility of realms beyond our own. So, let's continue exploring some of these concepts and examine how they might shape the future of cosmology. One of the most compelling and paradoxical ideas is the concept of eternal inflation. This theory builds upon the idea of cosmic inflation, which was proposed to explain the uniformity and flatness of the universe observed at large scales. According to the theory of eternal inflation, the rapid expansion of the universe during the first moments after the Big Bang didn't just stop, rather, it continues in some regions of space. In these areas, the inflationary process never ends, and new, pocket universes are constantly being born, each one separate from the others. These universes may have different physical constants and properties, meaning that life as we know it could be completely different in each one. The idea of eternal inflation leads to a mind-boggling conclusion: our universe could be just one of an infinite number of universes, each existing in its own bubble of space-time. This scenario is often referred to as the multiverse, and it proposes that the observable universe is merely a tiny part of a much larger and more complex cosmic structure. In this view, what we consider the edge of the universe is not a real boundary, but rather a limit to our observational capabilities. Beyond this limit, other universes may exist, each with its own set of laws, dimensions, and possibilities. While the multiverse theory remains speculative, it has gained traction in recent years as more scientists have explored the idea through various branches of theoretical physics. One of the most fascinating aspects of the multiverse theory is that it could offer explanations for some of the fundamental mysteries of our own universe, such as why certain physical constants appear to be fine-tuned for the existence of life. If there are infinitely many universes, then it's possible that our universe is simply one where the conditions happen to be right for life to emerge. However, the multiverse theory is not without its critics. Some argue that it's impossible to test or falsify the existence of other universes, which makes it more of a philosophical speculation than a scientific theory. Without direct evidence, it's difficult to know whether these other universes could ever be detected or whether they are even meaningful in our understanding of reality. Nevertheless, the idea of a multiverse continues to be a topic of intense debate among physicists, cosmologists, and philosophers alike. Beyond the multiverse, Another concept that continues to captivate the imagination of scientists and the public is the idea of extra dimensions. According to string theory, the fundamental particles that make up the universe aren't point-like objects but rather tiny, vibrating strings. These strings can exist in higher dimensional spaces beyond the familiar 3 dimensions of space and 1 dimension of time that we experience. Some versions of string theory propose the existence of up to 10 or 11 dimensions, many of which are curled up and hidden from our perception. If extra dimensions do exist, they could provide a way to explain some of the most perplexing phenomena in physics, such as the nature of gravity and the weakness of the gravitational force compared to the other fundamental forces. Extra dimensions might also offer a way to unify the different forces of nature into a single theory of everything, as they would provide a more expansive framework in which all forces could coexist. The challenge, however, is that these dimensions are incredibly small and compact, making them difficult to detect with current technology. The idea of extra dimensions raises another intriguing possibility, that our universe could be part of a much larger and more complex structure that we cannot directly observe. In this scenario, the edge of the universe is not a physical boundary but a point where the limits of our perception and understanding are stretched to their maximum. If we could somehow access these extra dimensions, we might gain insight into the true nature of space-time, gravity, and the fundamental forces that govern the universe. This brings us to the concept of brains, which is a key element of string theory and higher dimensional physics. A brain is a multidimensional object that can exist in a higher dimensional space. In some models, our entire universe might exist as a 3-dimensional brain embedded within a higher dimensional space. If this is the case, the edge of our universe might not be a boundary at all but a point where our brain interacts with other brains in the higher dimensional space. These interactions could give rise to phenomena like the Big Bang, in which 2 brains collided, creating the universe as we know it. If brains are real, they could have profound implications for our understanding of the universe and its boundaries. They might explain why certain aspects of the universe, such as the strength of gravity, seem to behave differently than expected. They could also provide a way to connect our universe to other possible universes or dimensions that lie beyond our perception. The possibility that our universe is just one of many brains in a higher dimensional space opens up new avenues for exploring the nature of reality. Of course, these ideas are still very much theoretical, and we are far from having definitive evidence for the existence of extra dimensions, brains, or the multiverse. The challenge of detecting such phenomena is immense, and it's unclear whether our current scientific tools will ever be able to probe the true nature of the universe on these scales. However, the pursuit of these ideas continues, driven by the desire to uncover the ultimate truths about the cosmos and our place within it. As we approach the limits of our understanding, it's important to remember that the edge of the universe is not just a physical boundary, but a point where our knowledge reaches its limits. Every answer we uncover leads to new questions, and every discovery deepens the mystery of what lies beyond. The search for answers will continue, whether through the study of distant galaxies, the development of new theories, or the exploration of new technologies that might one day allow us to peer into the unseen regions of space. In the end, the question of what lies beyond the edge of the universe may be less about finding a definitive answer and more about embracing the journey of discovery itself. The mysteries of the universe remind us of how much there is still to learn, and how much wonder remains just beyond the horizon. Whether we are contemplating the nature of space-time, the possibility of other universes, or the limits of human knowledge, the edge of the universe remains one of the most profound and intriguing questions of all. As we continue our exploration of what lies beyond the observable universe, it's essential to dive deeper into the concept of cosmic boundaries and space-time. These are the frameworks through which we understand the universe and its structure, and their mysteries only deepen as we probe further. Space-time, the very fabric that holds our universe together, is far from being fully understood. The way it behaves on the grandest and smallest scales is a matter of intense speculation and scientific inquiry. One of the most profound implications of the idea of cosmic boundaries is the realization that the observable universe itself may be just a tiny fraction of a much larger cosmos. The observable universe is limited to what we can see, roughly 46 billion light-years in every direction from Earth, where the light from distant objects has had enough time to reach us since the Big Bang. But this observable limit isn't a real boundary in space. It's simply the limit of our observational tools and the finite speed at which light can travel. Beyond the observable universe, things become speculative. The universe itself might continue on for an infinite distance, with galaxies, stars, and other cosmic structures stretching out far beyond what we can currently detect. This doesn't mean that the universe has an edge in the conventional sense. In fact, the concept of an edge, as we typically understand it, doesn't quite fit when applied to the cosmos. The universe might be infinite, or it could curve back on itself, much like the surface of a sphere, where traveling in a straight line eventually brings you back to your starting point. Some physicists propose that the universe is not only infinite in space but also in time. This raises the question, is there an end to time? Could the universe continue forever, or will it ultimately come to an end? While this question is deeply tied to the fate of the universe, it's important to consider that, even if time does continue indefinitely, what we perceive as the edge of the universe could still exist within a larger framework. This could mean that our observable universe is just a tiny part of an ever-expanding, eternally evolving cosmic landscape. The nature of the universe beyond its observable limit is also tied to the idea of spacetime itself. Spacetime is the four-dimensional continuum in which all matter and energy exist. It combines the three dimensions of space, length, width, height, with the dimension of time. In the theory of general relativity, space and time are intertwined. What happens in one dimension affects the other. For example, massive objects like stars and planets curve spacetime around them, which is what we perceive as gravity. But the question remains, what happens at the edge of spacetime? Some physicists believe that at the very edges of our universe, the laws of physics might begin to break down. This could be due to the extreme curvature of spacetime in these regions, where the usual rules of physics as we understand them no longer apply. In these areas, quantum effects might dominate, leading to strange and unpredictable behavior. This is why theories such as quantum gravity and string theory are so important, because they attempt to unify quantum mechanics, which governs the very small, with general relativity, which governs the very large. One of the most intriguing ideas about spacetime is the possibility that it might not be uniform everywhere. Some theorists suggest that there could be regions where spacetime behaves differently, perhaps due to the presence of exotic matter or other yet undiscovered phenomena. This could lead to the existence of wormholes, which are theoretical passages through spacetime that could allow for shortcuts between distant parts of the universe. If such wormholes exist, they could provide a potential path to explore regions beyond the observable universe, or even access other universes entirely. In addition to wormholes, the concept of dark energy is central to the ongoing expansion of the universe. Dark energy is a mysterious force that is causing the universe to accelerate in its expansion. While we don't yet fully understand what dark energy is, it is believed to make up about 68% of the total energy content of the universe. The nature of dark energy and its role in the cosmic expansion could offer clues about the ultimate fate of the universe and what lies beyond the limits of what we can observe. If dark energy continues to drive the acceleration of the universe's expansion, the distant future might see galaxies moving away from us so quickly that they become unreachable, essentially disappearing from our observable universe. The theory of dark matter also plays a crucial role in understanding the structure of the universe. Although dark matter makes up about 27% of the universe, it doesn't interact with light in the same way that ordinary matter does, which is why it's invisible to us. Its presence is inferred by its gravitational effects on visible matter, such as galaxies and galaxy clusters. Dark matter could be crucial to the overall shape of the universe and how it continues to evolve over time. As our knowledge of spacetime, dark matter, and dark energy continues to grow, scientists are also considering the role of quantum mechanics in shaping the universe. Quantum mechanics is the branch of physics that deals with the behavior of particles on the smallest scales, and it has been incredibly successful in explaining the behavior of atoms and subatomic particles. But the problem arises when trying to reconcile quantum mechanics with general relativity, as the two theories operate in fundamentally different ways. This disconnect suggests that we might be missing a deeper, more unified theory of physics that could explain both the quantum and cosmic worlds. One of the most tantalizing possibilities that quantum mechanics presents is the concept of quantum foam, at the smallest scales of space-time. This idea suggests that at scales smaller than even subatomic particles, space-time itself might become turbulent and fluctuate. These fluctuations could create tiny, short-lived wormholes or other structures that could connect distant parts of the universe or even different universes altogether. While this idea is still purely speculative, it hints at the possibility of a much more complex and interconnected universe than we can currently comprehend. As we approach the edge of our understanding, the question remains, what lies beyond? Is the universe infinite and eternal, with an endless expanse of galaxies, stars, and other phenomena stretching out forever? Or is there a boundary, a limit to space and time, beyond which nothing exists? Could there be other universes, each with its own laws of physics, emerging from the fabric of a greater multiverse? Perhaps the true nature of what lies beyond the edge of the universe is something we may never fully grasp, but the search for answers will undoubtedly continue to push the boundaries of human knowledge. As we look toward the future, one thing is certain: the quest to understand the cosmos is far from over. With each new discovery, we expand our understanding of the universe and uncover new mysteries that challenge our perceptions of reality. And while we may never be able to fully answer the question of what lies beyond the observable universe, the journey of exploration itself is a testament to the power of human curiosity and the endless pursuit of knowledge. As our exploration continues, it's important to touch on some of the most compelling theories that attempt to address what could lie beyond the observable universe. While the questions we are grappling with are fundamentally philosophical and speculative, they challenge the very limits of science and our understanding of reality itself. One of the key ideas that has emerged from these discussions is the concept of the multiverse. The multiverse theory. The idea of the multiverse suggests that our universe is just one of many, perhaps even an infinite number, that exist side by side or in parallel. Each universe within this multiverse could have different physical laws, constants, and dimensions. This concept stretches the idea of what is beyond the observable universe to something much more vast and complex. The multiverse theory is often considered one of the most profound and challenging ideas in modern cosmology and physics. In some versions of the multiverse theory, these universes might coexist in a higher dimensional space. They could be separated by invisible barriers or different branes, short for membranes, that exist within a larger cosmic framework. These branes could, in theory, collide or interact with each other, leading to dramatic events like the Big Bang itself. The concept of the multiverse has its roots in string theory, which posits that the fundamental building blocks of the universe are tiny vibrating strings. In certain models of string theory, these strings can exist in multiple dimensions, and when these dimensions are compacted, they give rise to the idea of parallel universes. There are different types of multiverses suggested by physicists, each based on varying levels of complexity. Some of the most widely discussed include 1. Level 1 multiverse. This version suggests that beyond the observable universe, there are regions that simply extend beyond the limits of our current detection methods. These regions could contain other galaxies, stars, and even civilizations, but they would be fundamentally similar to what we already know. 2. Level 2 multiverse. In this model, each universe within the multiverse could have its own set of physical laws. These universes could emerge from bubble collisions, where regions of space-time experience inflation in different ways, leading to universes with distinct laws of physics. For example, one universe might have a different strength of gravity, while another could have different fundamental forces at play. 3. Level 3 multiverse. This type is tied to the many worlds interpretation of quantum mechanics. It suggests that every quantum event that could happen in our universe spawns a new, parallel universe. So, if you flip a coin, in one universe it lands heads, and in another it lands tails. The idea here is that there is an infinite branching of universes, each one representing a different outcome of every possible quantum event. 4. Level 4 Multiverse. This is the most radical version of the multiverse theory. It suggests that all possible laws of physics and mathematical structures could exist somewhere within the multiverse. This theory proposes that any logically possible universe could be realized in some corner of the multiverse, and these universes could differ radically from our own in ways we can't yet comprehend. The notion of a multiverse challenges everything we know about the cosmos. If multiple universes do exist, we might never be able to detect them, because they could be fundamentally separated from our own universe in ways that prevent interaction or observation. This leads us to the question, is the multiverse theory something we can ever prove, or will it always remain speculative? The difficulty of testing this idea highlights the boundary between the observable universe and the uncharted regions beyond, where science and philosophy merge into a speculative realm of infinite possibilities. The concept of cosmic boundaries. Another crucial aspect of understanding the edge of the universe is considering the concept of cosmic boundaries. While the observable universe is limited to the light that has had time to reach us, what about the universe's actual edge, if such an edge exists? There are a few competing ideas about whether the universe has any boundaries, and these ideas have deep implications for our understanding of space, time, and infinity. One idea is that the universe could be finite but unbounded, meaning that while it has a limited size, it doesn't have an edge in the traditional sense. This is similar to the surface of a sphere, which is finite in area but has no true edge. The universe might curve back on itself in a higher dimensional space, creating a closed loop in which traveling in a straight line eventually brings you back to where you started. This idea is supported by the fact that the geometry of the universe appears to be flat, at least on large scales, which suggests that the universe could be infinite or curved in such a way that it loops back on itself. Another possibility is that the universe could be infinite in extent. If the universe is truly infinite, then its boundaries would stretch out forever, and the observable universe would simply represent the region from which light has had enough time to reach us. In this scenario, the universe would have no real edge, just an infinite expanse of galaxies, stars, and other cosmic structures extending beyond our reach. However, there are challenges to these ideas. Even if the universe were infinite, it might still have observable boundaries due to the limits of what we can detect. The cosmic horizon represents the farthest distance we can observe due to the finite speed of light and the expansion of the universe. As space itself expands, distant objects move away from us faster than the speed of light, making them effectively unreachable. This means that, even in an infinite universe, we may never be able to see or reach all that it contains. In addition to the cosmic horizon, there is another concept called the particle horizon, which marks the furthest point from which light could have traveled to reach us since the beginning of the universe. The particle horizon sets a limit on what we can observe and places a cap on our understanding of the universe's true size. Space-time and the edge of the universe. Finally, understanding what lies beyond the observable universe requires considering the behavior of spacetime itself. Spacetime, as described by Einstein's theory of general relativity, is the fabric that underpins the universe. It is a four-dimensional continuum that merges the three dimensions of space with time. The structure of spacetime is shaped by the mass and energy present in the universe. Massive objects, such as stars, planets, and black holes, cause spacetime to warp, creating what we perceive as gravity. At the edge of the universe, where spacetime might be stretched or even fragmented, it's possible that the usual laws of physics might not apply. In areas of intense gravitational fields, such as near black holes, spacetime can become distorted in extreme ways. These distortions might give rise to phenomena like wormholes, theoretical passages through spacetime that could connect distant parts of the universe or even lead to entirely different universes. However, spacetime itself may be more complex than we can currently comprehend. Some theories suggest that spacetime may be quantized at the smallest scales, meaning that it could be composed of discrete units, like grains of sand on a beach. If this is true, then at very small scales, spacetime might behave very differently, leading to strange quantum effects that could have profound implications for what lies beyond the observable universe. If space-time is indeed quantized, this could explain some of the mysterious phenomena we observe in the universe, such as the fine-tuning of the constants that govern the laws of physics. The fact that these constants are so precisely balanced in a way that supports life might not be a coincidence, but rather a consequence of the deeper structure of space-time itself. In the future, as our tools for observing the universe continue to improve, we may gain a better understanding of the true nature of space-time, the universe's boundaries, and the possibilities of what exists beyond them. Until then, the mysteries of the cosmos will continue to captivate our imaginations, offering an endless frontier of questions to explore. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.